We are going to begin with the very first experiment, that is separation of starch from potato. Let me give some idea about the starch. Starch is extensively used in the industry, whether it is food industry, pharmaceutical industry, or textile industry, or the paper industry. So starch really has good importance in the society. And we are going to begin. There are three important starches. Number one, and most widely used starch, is a cornstarch. Number two is a potato starch. And third one is a tapioca starch. So they are the important starches, and starches are present in many other plant, but these three are commercially important starches. We are going to demonstrate you the starch separation from potato. And here we have a potato, and this is the peeled potato pieces. And what we are going to do, we are going to make it from the pulp in a mixer. Bhakti is going to do that, and thereafter we'll be passing it through the mesh. Now the mesh which we are using it actually is about 60 mesh, and the starch grain of the potato is about up to 100 micron in diameter, and so it will pass through it actually, whereas the cellulosic material which remains behind, potato contains around 17% of a starch. Okay, and so we are going to pass it through the mesh. Whatever get passed through that will be the starch. Then we'll pass it in the beaker. We will allow the starch to settle down, which is heavier, and supernatant will decant it, and thereafter we will give the washing actually, just one more washing with the water, and thereafter we will try to dry it actually along with the solvent. Though commercially this particular method is not used, but for the demonstration purpose we are going to use methanol for the drying purpose to remove the remaining water from that. So Bhakti, please start with it. We have a peeled potato pieces, put it in a mixer. And what we will do, once we have the starch, then we will identify that starch both chemically as well as microscopically. Okay, so now what we are going to do, we are going to make a pulp out of it, pass it through it, do it fast. Yes, sir. Add more water. Yeah, make sure you put the hand, should not, yeah, go ahead. Do it more. Fine. Pass it here. Put it in immediately, instant. Okay, so now you can see here. Now we have put little citric acid because potato contains enzyme peroxidase, and if you don't put citric acid, it will start becoming brown. So it is important, if you want to have a absolutely white starch, you need to put slight amount of citric acid in the cut pieces. Okay, we have passed through this. Now you can see here the starch, which we are going to transfer it in a beaker. Okay, more. Put it, don't be. Wait a minute. Take this as well. No, take this as well. It's okay. Put it. Put it in this. We will discard this now. Discard it. Done. So now you can see here, starch will settle down. Supernatant will discard it and will replace it. Will give one more washing with the water. Yeah, I can see here the starch which is getting settled here. Fine. Okay. Of starch, at the base you can see the layer of the potato starch which has been settled. So Ankita, what you do, Decant the supernatant. Decant it. Completely, don't bother. Decant it. Quick. Completely get rid of the water. Enough. Okay. Add more water. Add more water in this. We'll give one more washing with the water. Okay. Yeah, enough. Okay. So now we have removed the initial water. Now we have put more water. We will allow the starch to settle down. Some cellulosic matter is still there that will float on the surface and that will discard it. And we'll get the pure starch at the base. In meantime, prepare for the filtration. Okay, get the filter paper and I will show you to make fluted paper. Normally you fold like this, correct? Correct, no? Okay, now you should fold like this. This is called the fluted filter paper. In conventional way, almost half of the paper or the area is not available for the filtration. In this, full area is available for the filtration. This is called the fluted filter paper and the entire area is now available for the filtration. Okay, all right. This has started. In meantime, we'll simply check it with the test tube, whether whatever we got it, whether it is having the now this is a starch suspension. In this you put iodine and see whether the color changes. Do you have a dropper or otherwise you can, okay. Yes, it has become purple. Yeah, so now you can see actually it has become purple. Why it has become purple, I'll tell you. The starch comprises of the two components, amylose and the amylopectin. Amylose is a linear polymer, amylopectin is a branch chain. Amylose gives intense blue color and amylopectin gives pink color with iodine. And together what you get is a purple color. Okay, so you can see here actually the purple color got developed here. All right, you are able to capture purple color? Okay, good. You can also see this under microscope. Okay, so what we will do, we will try to capture the starch grains under microscope. Same starch grain we will try to capture under microscope. Cover glass.